In this tutorial, we're going to talk about current and voltage in a parallel circuit. So we'll start by drawing a very simple parallel circuit. So we have our power supply, and in the circuit we have a resistor in the form of a lamp or a bulb, and in this part of the circuit we have another lamp or bulb. Now we're going to assume that for the purpose of this tutorial that those lamps are identical in terms of their resistance. If they're not identical, it complicates things a little bit, but which we'll come back to later on. Okay, so to start with, I want to look at the direction of the current flow. So the current, if you remember, the current is represented as the charge per second. It's a flow of charge through the circuit. It's a rate at which charge flows through the circuit. Now, a conventional current will go from the positive terminal to the negative terminal. So we have a bunch of charges, and they are going to flow from the positive terminal and then eventually back to the negative terminal. So the question really is, what happens at this junction point? We know that the charge is moving around the circuit, and then when it gets to this junction point right here, it has a choice to make. Now what will happen is the current will split, and in the case where the lamps are identical in terms of resistance, they will split evenly. So what will happen is we will have one charge go that way and one Coulomb charge go the other way. So the current splits. So what will happen is that change in color, this charge will move through that part of the circuit, and this other charge here will move through this part of the circuit, and then eventually the two charges will meet up to come back to the negative terminal of the battery. So I think from that diagram, it's pretty clear to see that the total current, I total, which we can represent as being in this part of the circuit. So if we had an ammeter in here, this could be the total current. Anywhere in the yellow branch would be the total current. Must be equal to, let's take this part of the branch, this one here, call that A1. This one here, call that A2. The total current will be equal to the current in the green branch, A1, which will be I1, plus the current in the blue branch, I2. So in a parallel circuit, the total current is equal to the sum of the currents in the individual branches. Okay, moving on to voltage. Well, voltage, or potential difference, is the amount of energy per Coulomb of charge. So let's imagine that we have our battery here, and our battery is, let's make it just 10 volt battery, okay? So that means that every single charge or Coulomb of charge that moves through the battery is going to gain 10 joules of energy. So these little charges here have each got 10 joules of energy. Okay, so 10 joules per Coulomb of charge. Now again, as those charges move from the positive terminal to the negative terminal, they're going to get to a junction point and they're going to split because the current splits. Now just because they've split, you'll notice that they still carry the same 10 joules they did before. And when they then go through the lamps, so this one here, put a voltmeter across, there's going to be a drop of 10 joules across that lamp. So on the left hand side, the electron Q will have, or the charge Q will have 10 joules of energy. On the other side, if we run along here, it will be reduced down to 0. And for the blue pathway, the same thing will happen. So we have a voltmeter in here, we'll call this voltmeter V2. The charge as it moves around the circuit will give up its energy to that lamp in the form of heat and light. And then of course the charges will rejoin in the yellow part of the circuit to collect more energy from the battery. So I think it's very clear to see that even though the current splits, the energy per charge does not actually change, and therefore the total voltage, which is the voltage across the supply, would be equal to V1, which is equal to V2. So the potential difference or voltage across parallel components is the same. And these are the two formulas that you will need to be familiar with in dealing with parallel circuits for current and voltage.